Hello everyone, in this video I will be solving merge to sorted lists problem. This problem you can find on Leetcode. Question number is 21. This is a famous question asked by major companies like Google and Amazon, etc. So let's read the question and try to understand. Merge two sorted linked lists and return it as a new sorted list. We have two sorted linked lists. This is the first list and this one is the second list. And we need to merge them and return as a new sorted list. The new list should be made by splicing together the nodes of the first two lists. So we will pick one node from here, one node from this one, then one here, one there, and merge them to create the new list. You can, if you don't know much about the linked lists, you can refer to Geeks for Geeks or Wikipedia or YouTube videos. There are some great videos on YouTube. I will try to go over quickly here. For example, this is the linked lists. Each of these elements are called nodes, and the first node is called the head, and the last node is called the tail. What we need to pay attention here is we don't know the size of the lists in the question, and we need to iterate through to find the ith node or the end of the linked list. So these are the things that we need to pay attention. In the question we are given two nodes, head nodes here, L1 and L2. We create a sorted iterator, a pointer we can say. It's sorter. So this node will be pointing to the value that is less than the other. For example, if you want to create a new list out of these two lists, what we need to do is first we will compare L1 and L2 and pick the less value, in this case 10. So S will be pointing to 10. S will be here. And we'll move L1 node to the next node. To visualize it better, what I'm going to do is I will create it here. I'll choose this node. Then we will compare L1 and L2 and pick the less value again. So this time it will be L2. And S will be pointing to this. The sorter will be pointing to this. And we'll move this to the next node. Again, we will be, now the sorter pointer is here, L1 is here, and L2 is here. Now we will compare L1 and L2 again and pick the value less than the other one. So this will be 30 this time, and we'll move the pointer, and next will be 40. We will compare L1 and L2 and it will be 40. Again, L1 L2 comparison, we'll pick 50. Then 60 here. Then 70. Then 80. Then this point L2 is pointing to null, and this is 80. Then we will simply here we'll simply put S sorter pointer here. So this will be pointing here, here, then it will be pointing to the rest of the linked list. So this way we'll create the new linked list. So let's write the rest as well. And we will return the head of this linked list, and that would be 10. The time complexity is of m plus n, the size of each linked list here, and space complexity is, we're not doing too many, we're only keeping a couple of variables, so of 1 is space complexity. Let's try to see it in the code to understand better. This code may look complicated at first sight, but after I explain, I think it will be easy. If we go through the, there are two ways of doing this. If we do it intuitively and go through the each of the node, first check if node is null, then second node is null, create the head node, check the values. That's pretty much what we're doing here. Check the value, find the value less value, and create the head node, then go through the while loop. This is if we do it this way, it's quite complex. I mean, there's too much code here. You may make mistakes here, so there's a better way of doing this, which is creating a dummy node in the beginning of the linked list node. So we don't have to worry about if the list is null or any of these values, because we have one dummy pointer right in the beginning of the linked list, and we will simply return dummy.next when we're done with all the code. So what we need to do is we'll delete this part and simply create a dummy list node. You can call it dummy, fake, etc. Usually you may see it like -1 or 0, but for you can put any number there. It could be 100, it could be 10, doesn't matter. We can put -1 as well. So this is the dummy node that is pointing, that is initially beginning here. Let's call it -100 or -1. Then we create the sorter node. This node will be sorting, that we talked here, sorter node. So that will be equal to the dummy node. So this is just a variable, temporary reference that we keep here in the dummy, because after sorting the linked list, we'll simply return the dummy node, dummy.next. That way we will bring the head of the linked list in the end of the computation. So what we need to do is we need to check if our nodes are null or not. This is the breaking condition for the while loop. If you remember what I said, when this one L2 hits null, L1 the sorting node is pointing to the end of the L2. So that's why we need to check if either of them, both of them, should be not equal to null. So we keep the while loop here. Inside the while loop, we need to check the values. If L1 value is less than L2 value, like here, like how we mentioned here, then the sorter node dot next is L1. So our sorter node is next is L1, and our sorter node is also L1. And so we basically put the sorter node here. If it's 10, it will be here. Then sorter.node.next is L1 as well. Then we move L1 to here, next new L1 position, which is 30. If the value is the otherwise, then sorter.next is L2. If this value is smaller, that will be L2. And sorter is now L2. And L2 is L2.next. So the reason why we're doing this is we are saying node is L1. You can also say node is node.next. That's why I'm just like making equal to L1. Node equals node.next. So next time when you're looking for the next value, you don't override the current value. That's why we're doing it here. Again, this breaking condition, we are in a null state in one of them. If after all this iteration, if one of these breaks, for example, L1 is null, and this while loop breaks, then we need to check here. If L1 is null, not null, means there are more items in the rest of L1 node. So we simply point our sorter to node.next sorter to L1. If L2 is not null, then we simply put sorter.next to L2. And eventually our dummy was pointing to the beginning in the node. So that's why we created dummy, in order not to write all the other code. That node, dummy node, now pointing to the beginning head of the linked list. So we simply return the dummy.next. So basically we create this in the beginning, and this is now pointing to this node here. If you go through it, I'm sure it's quite easy to understand. It's basically we have one dummy node and one sorter node that is sorting the linked list using comparison. So let's clean it. I guess this should now work. Submit and see. Okay, why is it so slow? Let's try here. Try again. Okay, now this is faster. When you clean the white space, etc., it's just like it's faster than 100% now. This is pretty much it, and you can also see other videos and other articles online. But what you need to do is basically just create a dummy node in the beginning and iterate using a sorter. And using comparison, you simply print out the result. Thank you for watching. I'll be back with other interview videos, and we'll continue solving more questions along the way. Hope to see you soon. Goodbye.